Hello students, welcome to my channel Nikita's Math Academy. Today we are solving exercise 1.1 of chapter 1 real numbers. So let's start with question 1. Use Euclid's division algorithm to find the HCF of following pair of numbers. Okay, so here we have to find HCF using Euclid's division algorithm. Now before this, let's just quickly revise what is Euclid's division lemma. It states that for any two positive integers a and b, there exists two unique integers q and r such that a equals to bq plus r. Q is quotient, r is remainder, and r is greater than equal to 0 and less than b. So this is the condition for Euclid's division lemma, and we are going to use its algorithm to find the HCF. Also, I have told you this method is similar to the method of finding HCF using long division method. Long division method for HCF we have already studied in our previous classes. So let's start. First, what we will do, we'll divide 225 by 135. So we'll get 135 ones are 135. Remainder will be 0. How will we write this in Euclid's in algorithm? 225 equals to 135 into 1 plus 9. Now again, the remainder is not 0. So we need to follow the same step. This time our dividend will become 135. So this will be 90 ones are 90. The remainder will be 43. So we will write this step as 135 equals to 90 into 1 plus 45. Now again, the remainder again, it's not 0. So let's divide 90 by 45. So you will find the remainder we are getting, it is 0. So in this step, we got our HCF 45 because remainder is 0. I hope you have understood this. Now we'll solve the question number 2 and 3 with same method. Now don't panic students because it's a big number. You just have to divide it, dividing bigger number by smaller number. Now 196 ones are 196. So you will get 186. Now take this 2. So now 196 times 54, 981, so it will be 86, 919, 70. So you are getting 8, 9. Let's take the 0. Now 5 times 33. Here you will find in the after dividing it, we are getting remainder 0. So in the first step only we are getting remainder 0. This means that 196 is our HCF. So what we did, we just simply divided it. Here we got remainder as 0 in the first step only. So we got our HCF as 196. Now let's try this third one. Again, we'll do the same thing. 867 divided by 255. So it will be 3. 3 5s are 15. 3 5s are 15 plus 1, 16. 3 plus 6 plus 7. So it will be 201. Again, we'll write this as 867 equals 255 into 3 plus. You can see remainder is not 0. So we need to do steps again. 255. 2 times 204. So 102 into 2, we got 1204. We are getting 51. Now again, we can write it in algorithm as 255 equals to 102 into 2 plus 51. Again, remainder is not 0. So we need to divide 102 by 51. So you will find in this step, we are getting remainder 0. This implies that this divisor is our HCF. Since we got remainder 0, so 51 is the HCF. I hope you have understood this. Let's move to the next question. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 and here is some integer. Okay, students, we are going to use our Euclid's division algorithm only. So what we will do, first we'll start by taking a, b, that positive odd integer, and let's take b as another integer whose value is 6. Now, using Euclid's division algorithm for a and b equals to 6, we have a equals to bq plus r, where q is quotient and r is remainder. Now for b equals to 6, it will be 6q plus r. Here the value of r, it will be greater than equals to 0 and less than 6. Now students, this is important step. This implies that the value of r can be 0 or 1 or 2, 3, 4 and 5. Now let's do all these cases. When r equals to 0, a becomes 6q, right? When r equals to 1, a becomes 6q plus 1. For r equals to 2, a is 6q plus 2. Similarly, a is 6q plus 3. A equals to 6q plus 4. And for r equals to 5, a is equals to 6 cube plus 5. So students, these are all the cases. Now here, we need to see that the a is odd integer. Now 6, it is even number, so 6 cube will also be even. So we can't take this number. Here it is plus 1, so definitely this will be an even number. It is plus 2, so it will be odd number. Plus 3, it will be even number. Plus 4 again, plus 3 is odd number. Plus 4 again, even number, so we can't take this. And plus 5 is also even number. So here you will find that the required form are 6 cube plus 1, 6 cube plus 3, and 6 cube plus 5. When q is some integer. Now let's solve next question. Any army contingent of 616 members to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Students, we have to find here maximum number of columns. We have to form for 616 members. Okay. Now for this, here what we need to do? The maximum number of columns will nothing but the HCF, right, is equals to the HCF of 616 and 32. Now we'll use Euclid's division algorithm. Using Euclid's division algorithm we'll use this for 616 and for 32. So let's again divide 616 by 32. So here you will find that after solving, here I'm solving. Here you can see the remainder which I got is 8. So this can be written as 616. It can be written as 32 into 19 plus 8. Remainder is still not 0. So let's divide 32 by 8. You can see here I got remainder as 0, and this can be written as 32 equals to 8 into 4 plus 0. This shows that 8 is our HCF. So 8 is HCF of 616 and 32. This implies that the maximum number of columns in which they can march is 8.